Good morning, all. I'm Professor Srilata from Sai Vidya Institute of Technology. I'm handling the subject computer organization. In this video, I'm handling the class on buses. Okay, so this is the bus which is in the system, which is in the computer. So you had seen in the previous videos that bus is something which carries the data. Okay, so you have seen that the devices, the functional units of computer, that is the input device, the output device, memory. Okay, so memory and processor are connected to the bus. Processor, all these devices are connected to the bus for transferring of data and signals. Okay, so bus is something which a set of wires which carries the information. So in daily life we see the buses, which is a vehicle which carries the people from one place to another. So it is transferring or it is transporting the people. Okay, so here the buses in the system is transporting the data and the signals. Okay, movement of data and signals take place in the buses. Okay, so we use the term bus for the wires which connects these internal devices. Now, uh, so bus is the device which bus is the thing which connects processor, main memory, and I/O devices, and it helps in the communication. There are three types of buses in the system. There are three types of buses: data bus, address bus, and control bus. Data bus is for the transferring of data. Okay, so any data to be transferred from one device to the other, that is from processor to the memory, it is put in the data bus. Address bus indicates the location with whom the transfer of data must take place. So address can be the address of an input device, the output device, or the memory location where the data has to get transferred. Address bus gives the location, that is the memory location, at which place the data has to be stored or from where the data has to be taken. Okay, or it gives the address of the device with whom the communication must take place. Fine. And there is control bus. Control bus informs the gives the signals like what type of operation has to happen, whether it is a read operation or write operation. Okay, and what is the status of the operation. All these signals are passed through this control bus. Okay, so suppose processor wants to communicate with the memory. Okay, processor wants to communicate with the memory, it wants to write the data to the memory. Okay, so it passes the data. Okay, so data is passed, suppose hello, data is passed to the memory, and at which location the data has to be stored, where the data has to be stored. Address is passed through the address bus, and the data has to be written, isn't it? That is passed through the control signal. Control signal has write operation. Okay, so that the data will be returned to the location which is mentioned. Fine. So other than the read and write operation, the control bus also contains the timing at which the data has to be put to the buses. Okay, the time when the data will be transferred, the control signals will be transferred, the time when, or the clock cycle when the data is received by the receiver. Okay, all such information is put in the control bus. Right. When this devices are, suppose here there are two devices, the processor and memory, which we had taken. Okay, the device which initiates the action is called as the master. The device which initiates the action is called as the master initiates, or it is called as initiator. Okay, and the device on which the work is done, okay, is called as the slave. The device addressed by the master is called as the slave. It is called as slave or target device with whom the master is communicating. Fine. So the two terms, master and the slave. Master is initiating the action. Okay. Based on the timing at which the data is put into the bus, and when the data is received by the slave device, okay, based on this, the buses can be classified into two types, grouped into two types, namely synchronous and asynchronous. By the term itself, you can know synchronous means in accordance with, okay, according to the timing. So works with the time, or you can say works with the clock. Okay, so there is a clock, that is time limit, and in that time limit, the process, that is the operation, read or write operation, is must be completed. Okay, next is asynchronous. In asynchronous transfer of data through the buses, there is no the time fixed. Okay, so it can take any number of clock cycles, but always in system, the activities, the operations is done faster. Okay, try to be completed faster. We'll see the synchronous and asynchronous groups in detail next. So asynchronous bus you have seen. Here a timing is followed. Okay, so follow timing information, that is a common clock cycle clock is maintained, which is noticed by both the server, that is both the master and the slave, and the communication, that is the transfer of data takes place. Okay, so there is a clock. So you can see here the bus clock. So a clock is fixed. By the end of this clock cycle, the operation should be completed. The read or write operation should be completed. So from one device to the device 1 to device 2, the data should have transferred during this clock cycle. This is one type of synchronous bus, where in one clock cycle, the clock width is fixed. That is, this width is fixed such that the slowest device, the farthest device also receives the information. Okay, so we'll see what is this and what is this clock pulse, that is a racing edge, and what happens during the second half of the clock pulse. Okay, so here this is the timing diagram. Timing diagram is used to represent the activities that what happens in the when data is transferred. So data has to be transferred from one device to the other device. Okay. So as you know, the device, that is the processor, suppose processor should send the address of the device D2 whom it should contact. Okay, the processor should send the address. The processor should send the signal, control signal, that is a read or write operation, what has to happen. And if it is read operation, processor wants to read the information from device D2, then data is not passed. There is no passing of data. If it is the write operation, processor wants to write on the device D2, then data also has to be passed. Correct? So address and control signals or commands has to be passed by the initiator. Okay, initiator has decided with whom it wants to communicate. Initiator has decided who is the slave. Okay, and so the slave's address is passed through the bus, address bus. Okay, and the operation what has to be done is passed through the controlled signal bus. Okay, so whenever I am passing the address, so first at the master, whoever the master is, we are taking it as a processor here. Master has to put the address first in the address and command or control bus. He has to put the address and the control, whether it is a read or write operation. Okay, as you know, address will contain the address of the device, that is D2, with whom it wants to communicate. So address bit pattern consists of ones and zeros, correct? So this is the bit pattern. It contains the address of the other device or port number of the device with whom the communication has to take place. Okay, so it contains a combination of ones and zeros. And if this is 1, this line is 0 in the particular signal. So it can be a combination of ones and zeros. So data is put in the address bus. So at time t naught, the data is put, that is the address is put in the, sorry, not data, the address is put by the master to the address bus. Okay. Now, this address passes through the address bus. This is the address bus. Okay. You have seen earlier, a single bus consists of 3 buses. It contains address bus, data bus, and control bus. Now, master has put the address and control signals through the control bus. It will be received by all devices. Suppose this is the processor. You had seen the diagram, single bus structure diagram. So this bus is connected with all many devices, many IO devices, and the memory, hard disk. Okay. So it is connected with all those devices. Now all those devices receives this address, and this address is decoded, and control signals are decoded, and in the interface circuit of this devices, it checks whether the address which is being passed is this particular device address. Okay, so master has put the address. Suppose it has put the address of keyboard, is put. Processor wants to communicate with the keyboard. Okay, there are many devices which is connected: printer, monitor, keyboard here, suppose hard disk. Okay, so all those devices are connected. All the devices can see this address which is passing through the address bus. All the devices interface circuits retrieves the address from the address bus and checks whether the processor wants to communicate with this particular device. Okay, and it matches the address of the device with the address which is coming through this bus. Now the keyboard address matches. Okay, keyboard address matches. So keyboard comes to know that it has to write the data by using the control bus, that is signals which is coming in the control bus. It receives the control bus data. It finds that the data has to be read from the keyboard. Okay, so the keyboard reads the data and has to put the data to data bus now. Okay, so the keyboard, by the time from T0 to T1, the address is decoded. Okay, address and control signal is decoded, and it matches, finds the slave finds out that it is the device with whom the communication request has come. Okay, now it is the read operation which we are seeing. So in this read operation, the data is taken. Okay, so here in the initial cycle, there is nothing, there is no data to the data bus. By this time, by the time T1, the device comes to know that it has to read the data, and it reads the data and puts to the data bus. Reads the data and puts to the data bus. Okay, once it is put to the data bus, That is the end of this operation, synchronous operation. Okay, note that in synchronous operation, there is no acknowledgement from the master that it has received the data, or there is no acknowledgement from the from the slave after receiving the address is matched. There is no acknowledgement that the address is matched. Okay, once in this particular clock cycle, the address is supposed to match. Okay, and the data will be present in the next clock cycle. Okay, so this address will go on till the next clock cycle also in the address bus. Fine. So the clock pulse, the one half of the clock pulse is decided such that the farthest device, which is at a different end of the processor, the farthest device will get the signal address and will be able to decode the address and control signals during that time. That is, if I suppose this is the farthest device, hard disk, and it needs 5 milliseconds to read the address which has passed. Once it has started at 0 milliseconds, suppose it has put into this address bus, okay, and the time taken to reach to the hard disk and decode the data and find out that this is the slave is 5 milliseconds, and this is the longest, means slowest device, farthest device to receive this particular address. Okay, then this width is fixed as 5 milliseconds. Okay, what I am telling is the device which is at the farthest end and with a low propagation, means a higher propagation delay is high. The time taken by the slowest device is fixed as the half of the clock pulse, 5 milliseconds. 5 milliseconds is the least, the means the most time which is taken by the device. Okay, when 5 seconds is the highest time which is taken by the farthest device, so that time is fixed as half clock cycle. D1 retrieves the address and decodes the addresses in 1 millisecond. D2 is able to retrieve and decode in 2 milliseconds, and suppose the keyboard is able to retrieve in 4 milliseconds. Okay, hard disk is taking 5 milliseconds, so 5 milliseconds is the maximum time taken in the device, and that is fixed as the half clock cycle. That means from T0 to T1, during this interval, from T0 to T1, during this interval, the task of finding the device and matching the address must be completed wherever the device is. Okay, in the next half of the clock cycle, the data should be put. Okay, when it is a read operation. Fine. So that is the concept. Now we'll see the same diagram. So here I just drew with by hand here to make the understanding better in this online session. So here address is put by the master and master places the address at time T0. Okay, indicates that it is the read operation which has to happen, and by T1 the slave has recognized the address and data is started to put at T1. Okay, by the time data started to put, the master will start reading the data. Master will start reading the data in the next, in this particular clock cycle itself, once the data is found. Okay, and by time T2, master should have read the complete data. Read operation must be done by the time T2. So in this one clock pulse, the complete operation must be completed. Okay, the whole operation must be completed. That is synchronous bus. And one more timing diagram we'll see. Okay, now in case of write operation, if it is the write operation from the processor end, means the master, we are taking here the example as processor. The processor wants to do the write operation. Okay, write operation is done. Means the processor is writing the data to the data bus. Okay, So at time t naught itself, the processor puts the data to the data bus. Okay, it puts the data to the data bus, and data is present. Okay, the slave recognizes it during t naught to t1. It recognizes the device who's the slave device, and the slave device comes to know that it has to read the data from the data bus. Okay, it is the write operation from the processor which is going on. So the data is returned to the device, that is a monitor or the printer. Okay, so printer or monitor must read the data from the data bus which is already put. So reading operation takes place in the second half. So data will be there till the end. Okay, so in case of in case of write operation, the data is put initially itself. Okay, if it is the write operation, data is put here by the processor, and data will be present in the data bus till the end of this T2. Okay, now you can see here there is a line which shows here, it means that it is about the next operation. In one clock cycle, one operation is completed. Okay, so this is for the next operation. Yes, slave probes the data, slave takes the data. In case of write operation, slave take the data by time t2. Okay, so this is synchronous bus, and now we'll see the status when the data will actually be seen by the master and when it will be seen actually be seen by the slave. Okay, we'll see in the same in this particular diagram. So I have told you that at time t naught, data is put to the bus, address is put to the bus. Okay, but here you can see there is a delay at time t am, not at t naught. After some time, the address is put to the address, and the command, that is control signals, are put to the bus. Why is this delay? This delay is because some time was taken for the complete address to be in the bus. Okay, at that instant itself, it is not visible in the bus. Fine. There is some time taken for the movement of data in the bus, for the filling of the whole address in the bus. Okay, so that time taken is the small time which is shown. Okay, now what we are seeing is the same read operation, that is, master wants to read the data from the device D2. Okay, as usual, master is the processor in our example, and here D2 device is the keyboard. Okay, we'll take this example. So this is D1 is the processor. Okay. Okay, and the communication is taking place between the processor and the keyboard. Fine. Master is the processor. So processor is undergoing the read operation. It wants to read the data from the keyboard. Okay. We'll see in this particular timing diagram when the data will be visible by the master in the bus, and the same data when it will be visible by the slave. Okay. Now suppose master, that is a processor, puts the address in the address bus. It puts the address at time 0 milliseconds. Okay, at some time 0 milliseconds, it puts the data to the processor. It will be visible by the client, or sorry, by the slave at the same 0 milliseconds. No, there is some propagation delay. There is some time taken for the movement of this address till the keyboard. The keyboard, the data has to move through this electronic device circuit. okay, and reach the interface circuit. It has to be decoded at the address has to be decoded, and the control signals has to be decoded and sent to the processor port, keyboard port. Okay, so some time was taken. Suppose I take it as 5 milliseconds. Okay, there is some delay. Fine. Now that's why. So first operation, what has happened is at time TAM, the master has put the data to the put the address to the address bus and control signals to the control bus. It is seen by the slave. When it is seen by the slave, so here this is two divisions actually. Here I'm going to, there will be another address and control signal as seen by the slave. Okay, so slave sees the data, sees the address at time TAS. Okay, so this is TAS as seen the address by slave, and this is TAM, address seen by the master at time 0 milliseconds, and this is 5 milliseconds. Okay, address as seen by the slave. Fine. In this case, in this keyboard case, okay, once the data address is seen, the address has to be cross checked. It has to check whether it is its address. Okay, after checking, the data is put to the bus, data bus at time TDS. Okay, at time TDS, the keyboard puts the data to the data bus, and it is visible at time TDM. The data is visible by the master. Okay, it is two different time because of this propagation delay. Okay, time taken for the movement of data. Fine, data reaches the master at after some time. Fine. This is about the how the read operation takes place and the timing diagram of read operation. Okay, signals do not appear as soon as it is put to the bus. There is some propagation delay in the interface circuit. Okay. Now it yes, the data transfer has to be done in one clock cycle, and the processor assumes that the data is available at T2 time. Okay, assumes that the data is available. There is no acknowledgements which is sent in case of asynchronous bus. Okay, everything is an assumption. The processor assumes that data has come here already and takes the data whatever is there in the data bus. Okay, there is no acknowledgement, there is no information from the slave that it has started to put the data to the bus. Okay, in case of synchronous bus, but it is in synchronous. That means at this particular clock time, this data is supposed to be put by the slave in case of read operation. Okay, so that is the synchronous bus. Next, we'll see what about multiple cycle transfers. Now here there is a single bus transfer, a single clock transfer, means in a single clock cycle the data has to be transferred. Okay, so the problem here is the width of the clock cycle must be such that the width must be such that, that is T0 to T1 must be such that the slowest device is able to retrieve to decode the address and check whether it is its address. Okay, means this must be the longest width which is required in the system. Okay, so all the devices slows down. Okay, hard disk which is faster to inputting the data must also wait till the time T1 reaches, and then only it can start putting the data. Okay, so there is a delay, there is all the devices slows down, means it waits till the time T1 is reached, that is half clock pulse is complete. Okay, so multiple cycles transfers can be done where there are several clock cycles involved in one operation. Okay, so one read operation, several clock cycles are involved. There is no restrictions on number of clock cycles in which that operation has to be completed. Okay, the now any number of clock cycles can be used in, this is same under the synchronous bus division. Fine. So how this is done, how does the processor know that the data has come, or till when will the processor wait? If it is a slow device, okay, time was taken for the signal to reach to the device, address to reach to the device, and it will start putting the data slow. Whereas in a faster device where the which is nearby to the circuit, it gets the address faster and it starts putting the address to the, starts putting the data to the data bus, correct? So how will the processor know when to receive the data? So there is something called as the slave ready. Okay, so slave ready signal is used. We'll see what is slave ready signal. Here you can see the clock pulse, number of clock pulses are used. It is not a there is no restriction, but time is consumed. When the clock pulse increases, that means the so much time is taken to complete one operation. Okay, so here we'll see, first see the address and command bus, that is the control bus. Okay, so it is shown separately in this diagram, nothing special. Just this is the diagram which is shown in the textbook, and hence I have put the same diagram. It is the same combination of as you had seen in the earlier diagrams. It is the same address and command in the, it was shown in the same diagram, same timing there. Here it is shown in different timings. Okay, timing diagram. So it is the same, address and command is put at a time t a m to the buses, address bus and control bus. Okay, after some time, one of the slave, whatever it is, keyboard or whichever device, okay, after some time it recognizes the address. Okay, once it recognizes the address and once the data is ready to be put to the bus, okay, again this is the read operation. Okay, the slave ready signal is sent. Okay, slave ready signal becomes up. That means the slave is ready to put the data to the data bus. Okay, it starts putting the data to the data bus and slave ready signal is up. So it is an indication to the processor that the data, to the master, that the data is present in the data bus. Okay, and the data is taken, is read by the master. Okay, and that is the end of this operation. Now this can be extended or this can be reduced. Here this timing can be reduced or timing can be increased also. What is this timing? To find where the, to find the slave device and match the address, decode and control the decode the address and control signals, okay, and match the device address. So this is the time taken. It can increase or decrease. Okay, so number of clock cycles involved in each operation and varies from devices to devices. Fine. So here address and command request. So slave places the data in the data bus, slave ready signal is up, okay, and master stops the data into the input buffer, to its buffer, master's buffer. Okay, hope the terms are clear. It is the master is the initiator who initiates this transfer operation. We are taking the example as processor. Okay, so example as processor, and the slave is the device whom the master is addressing. Okay, and we are taking the example as keyboard. Okay, we are reading the data from the keyboard. Keyboard puts the data here. Okay. Now we'll see what is asynchronous bus. In asynchronous bus, the data transfer is not, there is no common clock cycle. Okay, there is no common clock cycle, and it is the data transfer is controlled by two signals, that is a master ready signal and slave ready signal, by the form of handshake. Okay, by the form of handshake. Handshake means there is always an acknowledgement from the master and from the slave. Master puts the address and says that the master is ready. It does its work and says that it is ready. Okay, slave makes the data ready and informs that the slave is ready. Okay, so from this master ready, the slave will come to know that something is being put. Okay, there is a handshaking, there is some um, acknowledgements between each device, between those devices. Okay, and that is why we say the term handshaking. When acknowledgements is there, information sharing is there. Okay, so that is in asynchronous bus, there is no common clock cycle. Okay, with the help of the by signaling using the technique of handshake. Okay, by using the signals, master ready signal and slave ready signal, the communication or data transfer takes place. Fine. So what happens in the data transfer? As usual, master places the address and command information on the bus and asserts the master ready signal. It puts the master ready signal, okay, and indicates to the slave that the address and command informations are placed in the bus. The address is decoded by the slave, and once the slave recognizes the address and the data is ready, the slave ready signal is up. Okay, once the slave ready signal is up, master recognizes that the data is being put in the data bus. Okay, and it starts reading the data. Okay, it starts reading the data, and now already the slave is decided, and no more the address and command informations are required, because slave has read the address is matched, and it has come to know what operation has to be done by using the command information. So it removes the signal, master removes the signal. Okay, and the reading operation will be completed. Okay, so this is the process we are seeing for the same, the read operation. Okay, for the read operation, for the same read operation we are seeing, that is master or the processor is reading the data from keyboard, which is the slave. Okay, so first master places the address. So master is placing the address at time t naught. It has placed the address and the command signal. Okay, and once the data is put by the next by t1, by the time t1, the master ready signal is up. Okay, master ready signal is put. Once the master ready signal is seen by the slave, so what does the slave do? Once the master ready signal is seen by the slave, slave checks the address. Okay, one second. So at time t1, master ready signal is set, and at time t2, the slave would have checked the address, what is there in the address bus, and the slave ready signal is made up. Okay, the slave ready signal is up, and this master, due to this master ready signal, the slave ready signal has come. Okay, the slave is ready to put the data, and it puts the data to the data bus. It puts the data to the data bus. Once the slave ready signal is up, the master comes to know that the slave is already set, okay, and the slave device is agreed that it is its address and its operation is already in progress, that is the read operation is already in progress, okay, and so master removes the address and command information. So when the slave is ready, the master comes to know that the slave ready signal is up, okay, and so what does it do? It removes this address and command signal from the bus. Okay, it removes this address and command information. And once it is removed, the the master is made down because the slave is already set, and it removes the address and command information. So after removing the address and command information, by two cycles, by two clock pulse, the data would have already been put to the data bus, okay, and so the by seeing this master being down, okay, because it is the slave has set, okay, the master comes down because the slave is already set, and now by seeing this slave which is already, okay, the master which has set, it comes down, it brings down the slave signal, okay, the slave signal comes down because the particular operation is completed. Okay, particular operation is completed. Okay, at time T5, slave receives the transition of the master ready signal. Master ready signal has come down. Slave receives this information that it has come down. Okay, and by two clock cycles, it would have also completed its task. So slave ready signal is also down. Okay, so this is the read operation in asynchronous bus. Fine. So you can see there is a handshake between this each and every task which is happening. It has received the information from the previous time. Okay, it has received some information like master is set. So this is the first event which set. Okay, once the master is set, by seeing this, the slave is also recognizes and it is set. Okay, once the slave is set, master comes to know that the slave is set and the operation, that is a read operation here, is already in progress. So the master comes down, third step. Once the master comes down, the master knows that the address and command information is no longer required, it is removed. Okay, the information, it gets the information, and also slave receives the information that the master is down, and so once the operation is complete, the slave ready signal is also down. Okay, each and every task what is happening here is by handshaking, is by the information what it has received in the previous clock cycle. From the previous clock cycle, whatever information it has received, the next task is due to that previous operation which has happened. Okay, and that's the asynchronous transfer. We'll just see the animated images. So the address is put, the master becomes ready. Once the master becomes ready, the slave recognizes the address and the slave is ready. Slave puts the data to the data bus. Okay, once the slave is ready by putting the data, the master comes down, the master signal is down. Okay, master ready signal is down. When the master ready signal is down, why master ready signal is down? Because it knows that the slave is already set, and that is the slave is already decided, the system is already decided which is a slave device, and slave is already in its operation. Okay, no more searching of other devices is required, so the address and the command signals are removed. Okay, once the master ready signal is down, the slave completes its operation within next two clock cycles and comes down. Okay, so slave ready signal also comes down, and that is the end of this read operation. Okay, suppose it was the write operation. What is the difference here if it is a write operation? If it was the write operation, the data would have come to the data bus in the initial stage itself. Okay, in the initial stage itself, data would have come to the data bus, and the slave will be ready. Once the slave is ready, slave is reading the data from the data bus, and as usual, the master ready signal comes down, and then after reading the data from the data bus, the slave ready signal also comes down. Okay. So the advantage of an asynchronous bus is it eliminates the need for synchronization. Synchronization is not needed here because we are using the master ready and slave ready signals, okay, and can accommodate varying delays automatically. Yes, if there is a delay in the device to recognize itself, okay, a device which is at the farther end from the processor, suppose there is a delay to receive the address and there is a delay to recognize the slave device, okay, it can go to the next clock cycle also, and the slave ready will be up here in this time, at time t3. Okay, and accordingly the shift happens, the it shifts. Okay, time consumed by this particular operation is increased by one more clock pulse. Okay. So that is the advantages of asynchronous bus. So that's about the asynchronous and synchronous buses, what we have handled in this class. So any doubts, you can always communicate. Okay. Yeah. Thank you.